Okay, this is YTSS Prelim 2022. So in this video, I will go through question 3, which is mainly on moment. So for some reason, we noticed that Cambridge paper will usually ask definition question in moment. And there's always this confusion. So there are two definitions in the chapter of moment. One is for principle of moment, and one is for defining moment of a force. So the definition of principle of moment, we test it many times. Basically, principle of moment is just a fanciful way of telling you that when an object is in equilibrium, the sum of clockwise moment and the sum of anti-clockwise moment about the same pivot is going to be the same. So that is the principle of moment. Basically, they tell you that when an object is at equilibrium, what will happen in terms of moment. Then there's a definition that defines what is meant by a moment, the moment of a force, meaning that what is the amount of turning effect caused by a particular force about a particular moment. And mathematically, it is summarized by m equals to F times d. So basically, to complete this definition, you have to tell me that it is a product of F and d. The problem with answering this question is that the d, the distance, is defined very specifically. So in physics, whenever you want to define distance, you need to tell me where is it measured from and where is it measured to. So I gave you this example. So here you will see that I have a system and it has a pivot here at the triangle, and there is a force being applied on this object, and obviously this force will create its own turning effect, which is measured by moment. So the distance that we are concerned with is that this distance is measured from the pivot, and it is measured to the line of action of a force. So this line of action alone doesn't mean anything. It is like saying the weight. What does it mean? It means nothing, right? Unless you tell me that, oh, it is the weight of this hamster or the weight of this fish, right? You have to relate this property. Weight is a property of a particular object, right? So line of action is also a property. So you need to tell me that this line of action is of what, and it is of the particular force that we are interested in. So now that I have this definition of distance is measured from the pivot, and it is measured to where. So this is where the pivot is. I will use green, right? It is measured to the line of action of the force. And this particular distance is not any distance, because if we just say distance measured from, let's say, the pivot to the line of action, it could mean this red color line. But we do not want this red color line. We only want one line, and that line must be perpendicular to the line of action of the force, right? So when you look at the definition in the OneNote, if you scroll down this page over here, you look for 4E Prelim, paper 2, you can scroll down and you will be able to find the definition of the moment of a force. If not, you can also refer to your textbook. So when you revise on the chapter of moment, there are two definitions. You need to make clear which one is the one that the question wants. For part B, it is a very typical question on moment. Most of you should have already completed your TYS, and in your preparation, you would have seen this question, right? If not, then it's time to reflect what happened to your preparation. So in this question, in part 1, they are asking you, what is this force acting on the orange beam? And actually, you need to find this information from the yellow beam. So if you look at the yellow beam, there are two toys, each 2 Newton. So what happened is that in order for this yellow beam to be balanced, the upward force and the downward force must be equal. So in another word, F1 must be 4 Newton. Now F1 is linked to the orange beam through this particular cable. So meaning that this upward force F1 is acting on the yellow bar, there must be a reaction force that acts on the orange bar, right? When I say orange force, I have to refer to this force to a different object, right? I said F1 acting on yellow bar is a reaction force to F2 acting on the orange bar, right? They are of different object, and they will have the same magnitude but opposite direction. So you can either solve it by intuition, or if you follow through your Newton first and third law, you'll be able to work out that this F over here is 4 Newton. After that, it is basically your typical moment question. Most of you make the mistake of not considering the full length because I purposely designed my question to break this length into two parts. And it is a typical trick used by Cambridge paper to test whether candidates are aware that when they are considering the turning effect caused by this 0.4 Newton, I have to take into account this length all the way to the pivot. So down here, you will see that there are three forces. Each of them will produce its own turning effect. You need to use your principle of moment, right? When you apply principle of moment, what it tells you basically is that the turning effect of 1, the turning effect of 2 must be equals to the anti-clockwise turning effect of 1, right? Whereby all the moment basically cancel out each other's turning effect. So if you equate them correctly, you'll be able to find that W equals to 1.3. Now at this point of time, if you are unable to solve such typical moment question, please leave your question in the comment. If not, just WhatsApp me. And remember to like and subscribe so that I can upload more videos.